Welcome to our session on reviewing the BAR model, a strategy for solving word challenges. Keep in mind that the BAR model is used to help you understand or visualize a word problem. It doesn't give you the answer, but it does help you figure out what is going on in the word problem so that then you can decide what operation to use. Okay, let's get started. There are some basic types of drawings that go with basic types of math problems, and I'd like to just go over these drawings first. So please look at this first drawing and see if you can figure out what math sentence would help us find out the value of the box that has the question mark in it. Okay, well, hopefully you recognize that we have 12 in the entire box, but part of that box is 4, and we want to know what is in the rest of that box. So the math sentence could be 12 minus 4 is equal to 8. Of course, I could have done it as a missing add-in and said 4 plus what is equal to 12, but I chose to use subtraction. Now let's move down to the second drawing and see if you can figure out what math sentence would allow you to find out what is inside of each box. Each box is of equal value, representing an equal amount. Well, if we have 18 in all, then we want to split 18 into 3 equal parts and find out what is in each part. So, of course, that operation is division. 18 divided by 3 is equal to 6. And again, I could have used the inverse operation and said 3 times what number would give me 18. And of course that would be 6. But I chose to write it as a division problem. So each of the boxes represents a value of 6. Here are 2 more drawings for you to try and figure out what is the question mark represents. If you will notice in the first drawing, you have 2 identical units, but one of those units has an addition of 3 to it. So what we know is if we could get rid of this 3, then we would have 2 equal units left. So the math sentence to get rid of the 3 would be 17 minus 3, which is equal to 14. Now I know the 2 equal units together are equal to 14, so to find out what one of them represents, I would do 14 divided in half, or divided by 2, which is equal to 7. So 7 is the value of the 1 unit. In the next drawing, you will notice that we have 3 equal size units, although 2 of those units are attached. But they're still of all equal size. So what operation would allow us to split 33 into 3 equal parts? And I'm sure that you know that 33 divided by 3 is equal to 11. So each unit has a value of 11. There are basic drawings in using the bar model which relate to basic math problems. I'd like to start off with those and then we'll progress to more difficult ones. This problem, which I'll let you read right now, is a fairly simple problem, but it will show you how the bar model works. We start with the questions, who or what's involved. We know Pete's involved. Sally's involved, but we aren't keeping track of her airplane, so we aren't going to write Sally's name down. I noticed that there's only one pile of stuff, Pete's airplanes, so I'm just going to draw one bar. Now I'll go back to the word problem itself and read it sentence by sentence and draw it sentence by sentence. Pete has 15 airplanes, so I would put my 15 here and draw the arrows to show that the bar, the entire unit, represents 15. Sally gave him 6 of them for his birthday, so Sally gave him part of this 15. So I'm going to split the 15, put the 6 in here. How many airplanes did Pete have before he got Sally's gift? So my question is, how much would fit right into that part of the bar? There's several different ways we could write this math sentence. We'll write it as a subtraction problem. 15 is what I have in all. I know one part is 6. I'm trying to find out what the other part is, and I know 15 minus 6 is 9. So Pete had 9 airplanes before he got Sally's gift. Go ahead and read this problem, then pause the video and see if you can draw it and see if you can find the answer. And then after you have finished solving it, go to the next slide and you can find one way of one solution strategy. All right, let's get started. It is helpful to identify who or what's involved in a problem, and we know that Madison has some stuff, money, and Michael has some money. Then I like to decide who has the smallest amount. And it says Madison has $21 more than Michael. So Michael has the smallest amount. So I'm going to give him the unit box. Now I go back to my word problem and make sure I draw in each sentence. Madison has $21 more than Michael. So Madison has the same amount as Michael with an additional $21. They have $135 all together. So I'll draw that in. How much money does Madison have? You want to make sure you put the question mark into your drawing because eventually these get so complicated you forget what you're trying to find out. Now when I look at my drawing, I notice it's the type that has 2 equal amounts, although one of them has an additional $21. So I'm going to eliminate or take away that 21, and I can do that in the math sentence. I have $135 in all, and I'm going to take away 21 of those dollars, which of course would give me $114. So the two boxes that have the equal amount have a total of $114. Now I want to find out what is in one of those boxes. So I would split my 114 in half, or divide by 2. And of course that is equal to $57. So there's $57 in each one of these boxes. And I'm trying to find out how much Madison has. So I would need to add together the $57 and the $21. And of course that is equal to a total of $78. So Madison has $78.